Hello everyone, welcome to Coders Camp. We are at 9th day of December LeetCode challenge and the problem we are going to cover in this video is jump game 3. So we have already covered a few other jump game problems. So let's see what is here. So the input given here is an integer array nums and an integer value start, and we are going to stand at the position or index start, and we can jump either I plus the value at the index or I minus the value at the index, and we have to return true or false if we can reach any index with value 0. So let's understand this with an example. So here is a given example in the problem statement, and the start value given here is 5, which means we are standing at the position 5 or index 5, and we can either jump by the index plus 1 or minus 1, which is simply plus the value given in the index and minus the value given in the index. Suppose we have two ways to start from this index. We can either travel to the index 4 or we can travel to the index 6 because the value given here is 1. So let's explore both the paths. So starting from index 5, we can either travel to index 3 or index 4 or index 6. So now from index 4, the value is 3. So again, we can jump from index 3 to 3 plus 3 positions. So we don't have other path this side because we don't have 3 elements after index 4, so we have to jump backward. So 1, 2 and 3 we will be landing at position or index 1 with value 2. So now our tree grows towards from index 4 to index 1. So now we are at index 1. From here the value is 2, so we can either jump forward by 2 steps or backward by 2 steps, and we don't have any elements left in the backward to jump because the value is 2, so the only way to go is forward. So when you jump 2 steps forward, it will land you at 0 and you have reached the destination where we have to reach, and we are going to return true. So this is one way. From index 1 you'd be reaching index 3, which is having the value 0. So you can either come by this way or you can take the other way. So consider we are at index 6 by jumping from index 5 to 6. So from index 6 we have value 2. So by using value 2 we can jump 2 steps backward, and we have again value 3. From 3 you can again jump to 3 steps backward. That again traces through the same path we have traveled, that is from index 1 again to index 3. So from 6 you have traveled to index 4, and again from index 4 to 1 and 1 to 3. So this is another path. So instead of directly traveling from 5 to 4, you take a D route to travel through index 6 to 4, and again the same path follows. So this is another way to reach, but either way we have reached our destination and our result is going to be true. So how are we going to approach this programmatically? So if you think of what are the possible techniques we can use to solve this problem, if you observe the problem keenly, we have to explore n number of paths that is making us to reach a destination. So another point you can notice, the path can be the same again, that is the path can be repeating like similar to this. But if there is a path, if there is an index you reached and from that index you cannot reach to 0 at all, then you should not retrace that path at any cost, because once you cannot reach from that position, from whatever position you reach to that position, you cannot reach to 0. So hope I made sense. So now there are 3 ways to solve this. Either you can use a BFS or DFS algorithm for traversing all possible nodes, and finally when you reach the node with value 0 you can return true. So you can again solve them using an iterative BFS or recursive BFS, and again iterative DFS or recursive DFS, both of them would do. So we have covered n number of times how to do an iterative BFS. So you can use the same way to put the index of the position at our queue and explore the paths from here, that is 4 and 6, add them back to queue, and from popping this out you can further proceed with the other 2 indexes in queue till you reach the value 0. So this is one way you can go for again the DFS approach. So in this video we are going to see the DFS approach which is in a recursive way to solve this problem. So let's see the code now. So as I said, we are going to solve this problem using recursive DFS, and for any recursive algorithm we have to figure out three things and we are done with solving the problem. So the first thing is base condition, the second one is recurrence relation, and the third thing is when we have to return our result. So if we are sure about something, then that is our result. So if our array of value is equal to 0, then we have to return true. So the array of value will be our start, because here in recursive algorithm we are using start to identify the current index we are at. So if the value at current index is equal to 0, then true is going to be our result. So this is done. The next thing we are going to do is recurrence relationship. So what is a recurrence relationship here? So as I said, if we landed at some point, we are going to first check if the value is 0, then we are going to return true. If the value is not 0, then we have to explore two other possible ways. So that is what we are going to do. So we are going to call it recursively, and we are going to pass the same array value with at which index we are going to jump to. So we have two ways to jump, that is the current index value plus the value at the current index, which is nothing but the forward movement. If not, the current index value minus the value at current index, which is the backward movement. So yes, we are almost done with our part, just that we have to cover few base conditions and the conditions which doesn't make the loop run infinite times, and we are done. So now we have to check the base conditions, that if we are generally doing the plus and minus, but we have to make sure that the index doesn't go beyond the actual index of the array or less than 0. So we are going to check both the conditions here. So if start is less than 0, then return false. Same way, if start goes beyond the array's length, then also we have to return false. Yes, we have covered these two conditions, and one more condition we have to do is the loop thing I said. So once you land at a position, from there you cannot reach to 0 at all. Then whenever you land at the same position, you cannot reach to 0. So we should not traverse back in the same path again. So to identify this, your program must have a memoization or some data structure that tells you that you have already visited this path, so you don't have to really go back again there. So we have to maintain a data structure. Here I'm going to use a set. So here I'm going to check if the value is 0, then return true. If not, we have to put the node's value or the index in the visited set, so that we could identify whether the node has been already visited or not. So we are going to add the index to the set. So every time we are going to check if the node is already been there in the set or not. So if visited contains the index already, then we cannot reach 0 from that index. So we are going to return false. So yes, this is it. Let's run and try. Yes, so let's submit. Yes, we have submitted today's code and it runs in 11 milliseconds. So thanks for watching the video. Hope you like this video. If you like this video, hit like, subscribe, and let me know in comments. Thank you.